Welcome once again to my YouTube channel. Today we are taking a physics topic, latent heat. The latent heat, hidden heat, a heat that cannot be detected by a thermometer. So what's this very latent heat? Latent heat is a quantity of heat required to change states of substance or substances from one form to another form without changing temperature. I repeat, latent heat is the quantity of heat required to change state of a substance or substances from one form to another form without change in temperature. Latent heat is responsible for change in state of a substance. When a substance changes from solid to liquid or vice versa, the heat that is responsible is termed latent heat of fusion. When that very liquid turns to gas or vice versa, the heat that is involved is termed latent heat of vaporization. Now, when we consider a unit mass, then we now consider the term specific. So we can put up a specific latent heat. We can now define specific latent heat as the quantity of heat required to change the state of a unit mass. That's 1 kg mass. From one form to another form without change in temperature. I repeat, the specific latent heat is the quantity of heat required to change a unit mass, in quote, 1 kg mass, from one form to another form without change in temperature. When a unit mass turns from solid state to liquid state or vice versa, the latent heat there is termed latent heat of fusion. When liquid turns to gas or vice versa, the quantity of heat responsible there is termed latent heat of vaporization. So, specific latent heat is responsible when a unit mass changes from one state to another. Now, let's move into calculation. Okay, we have two questions on the board. The very first question reads, calculate the quantity of heat energy required to change 20 kg of ice to water at 0 degrees Celsius. Specific latent heat of fusion is 366 exponential 3 joule per kilogram. Now, let's look into this. Now, in order to solve this question number one, from the definition, we say that the specific latent heat, which I can represent with letter L, we said that it is the quantity of heat. This is the quantity of heat required to change a unit mass. This is the unit mass, okay? To change the state of this unit mass from that very form, which could be solid, liquid, or gas, to another form. That is the mass. So specific latent heat represented with L is equal to that quantity of heat required to change this unit mass, okay, from one form to another. Now, the unit specific latent heat is joule per kilogram because heat is measured in joule, then mass is measured in kilogram. So we have the unit as joule per kilogram, okay? So in this very case now, if latent heat is equal to H over M, that means H will now be equal to ml. So we have to consider this as a formula. Now, to solve the question given to us, calculate the quantity of heat required. So we are asked to find what? The H, which is the quantity of heat required to change 20 kg of ice. So the mass is 20 kg, okay, to water. at 0 degrees Celsius, where the specific latent heat was given as 366 exponential 3 joule per kilogram. So in order to find these very heats, we use this very formula. Okay, so we are going to have H equal to ml. So they have the heat given as mass, which is 20 kg. We have 20 times the latent heat, that's the specific latent heat, which is 366 exponential 3. So if you simplify this, we have 20 times 366 exponential 3. Then we are going to have H equal to 732,000. So here we have the value in joule, that's the quantity of heat. So heat is measured in joule. So we can take it in this very form to standard form: 1, 2, 3, 4, 5, 6. So we have 7.32 exponential 6 joule. So that gives the answer to number 1. So the next exercise, they said, calculate the specific latent heat of vaporization. Okay, so exercise 2, solution to it. Calculate the specific latent heat of vaporization. So specific latent heat, which I represent with L. So we are now asked to calculate the specific latent heat of vaporization. If 1.13 exponential 7 joule of heat is required, then the quantity of heat is 1.13 exponential 7 joule. It's required to convert 10 kilogram of steam to water. So we have the mass, which is 10 kilogram. Now, the formula for specific latent heat is equal to H all over M. So if we substitute, we are getting 1.13 exponential 7 divided by 10. So if you divide this, we are going to get 1.13 exponential 6. The unit now will be joule per kilogram, and that gives the answer. So if what we did, we were able to help someone out there, please do subscribe, share, and turn on notification for others to learn as well. See you on our next class.